Hello everyone, this is the second video of chapter 3, topic on slope. In this video, you can use table and graphs to find the slope of a line by using changing y over changing x. So first of all, let's talk about what I mean by slope. The term slope is used to describe the steepness of a straight line. Slope is a ratio of the rise or vertical change to the run or horizontal change. So the slope is equal to rise over run, where the rise representing the vertical change between any 2 points, run represent the horizontal change between the same 2 points. Slope can be a positive or negative depending on what problem or what situation you're working on. So the first problem, find the slope of the treadmill. Using the slope is equal to rise over run. While I'm looking at this picture, there are some information that's given. The first information is my length from the left all the way to the right. The horizontal change is 48 inches. When I'm looking at the vertical change, so it looks like from the bottom to top, it's 10 inches. When I write the slope, my steepness will be represented by the rise, which means 10 inches, over the run, which is 48 inches. There is one more thing that I want to emphasize in here. Whenever you see a fraction, please do your best to simplify as much as you can. When I'm looking at this 10 and 48, the first number that comes to my mind is I can divide by 2 on top and bottom. So if I do so, 10 divided by 2, I will get 5. 48 divided by 2, I will get 24. And I notice they don't have any common factors, so that's how I know, okay, the slope is 5 over 24. Let's look into one more problem. A hiking trail rises 6 feet for every horizontal change of 100 feet. What is the slope of the hiking trail? So I'm asking you to find the slope again, where slope is rise over run. Oops. Then I've noticed that 6 feet is representing this trail's rise. So I'm going to put 6 on my numerator over the horizontal change is 100 feet. Remember, the horizontal change is the same as the run part. So I would get 100 on the bottom. One more step that you need to divide or simplify. So if I divide by 2 on top and bottom, the numerator will become 3 and denominator becomes 50. And as I see, this is the simplest form. For number 2, the graph shows the cost of muffins at a bake sale. Find the slope of the line. This one is, you can see I have a graph. When I have a graph, I'm still going to use the same thing. The slope is rise over run. So by looking at the graph from the first point that's given to me to the second point, my vertical change, another word, I'm going from here to the second point by going up 2. From this point, if I want to continue, my horizontal change, my running will be 1. So that's how I know my rise is 2 over my run is 1. If you simplify this one more time, you'll get 2. Let's look at number 3. The table shows the number of pages Garrett has left to read after a certain number of minutes. The points lie on the line. Find the slope of the line. So here, if I want to find the slope, we talked about it as slope is equal to rise over run. How am I supposed to know which number will be representing rise, which number will be representing run? The answer is written right here. They will tell you often which one represent x or which one represent the y. When I'm looking at the graph, the horizontal line is your x value. When you are graphing, your vertical line will be representing the y value. If I find the constant rate of change, so from 1 to become 3, which means I'm adding 2. From 12 to become 9, which decrease, so I'm going to subtract 12 minus what would give you 9? The answer is 3. So that's how I know my rise, which is your vertical change, the y value will be on the numerator. I'm going to write the rate. So minus 3 goes on the top. The run is your horizontal change, which is representing by the x. The number goes on here. You'd notice that any other number will have the same ratio because it lies on a line. That's a linear relationship. Just to double check, let's pick another one. 5 to become 7. 5 plus 2 will get you 7. 6 became 3. So 6 minus 3 will give you 3. You notice that my numbers are still same, and if you repeat the same step, you will still get slope is equal to negative 3 over 2. Let's look into a couple more examples. Find the slope of each line. So the first one I see is a graph. Here are 2 given points on a line. If I want to find the slope, again, slope is equal to, from one point to become the second point, I realize I'm going up 3. So that number will go to the numerator. I am running, so my horizontal change is 1, 2, 3, 4. It's 4. That's how I find the slope from the graph. When you are given with a table, again, the slope is still rise over run. Only thing is the rise is your vertical change, which will be representing your y. Your run is the x value, where it's representing the horizontal change. You can also use the proportional. Only thing is, again, when you have a 0, it's going to be either, the number becomes either 0 or not possible. So let's just find the constant rate of change as I'm going to the right. Negative 6 became negative 2. Both numbers are negative. However, I'm increasing my number, so I'm going to add. Negative 6 to become negative 2, I need to add 4. If you were struggling, you don't have to pick the first point. You can always find something else. So 2 to become 6, I'm still adding 4, and they have to be constant. For the y value, negative 2 became negative 1, so same thing. You are increasing the number, so I'm going to add 1. Again, you can do the same thing for the other point. So from 0 to become 1, I'm still adding 1. So again, the slope, when it's rise over run, this time let me write your y value over x value. So the y value was 1, that's your rate, over your x value, the constant rate of change for the x1 is 4. So that's how I can tell the slope is going to be 1/4. So far, you're looking at slope from word problem, graph, and a table. After this slide, you will need to find a slope from just 2 given coordinates, where the slope formula could be very handy. The slope m of the line passing through points x1, y1 and x2, y2 is a ratio of the difference in the y coordinates to the corresponding difference in the x coordinates. To make it a little bit easier, let me look at the symbols. So instead of me writing slopes over and over, they have decided we're going to use a variable m. This is very popular. So m is equal to, they're saying the difference of the y coordinates. So think about this way. When you were looking at the tables earlier, we were finding patterns. 1 became 3, 3 became 5. If I want to find the pattern, my numbers are increasing, so I'm going to add by the 1 to become 3, I need to add 2. 3 to become 5, I also need to add 2. Sometimes a number could be also found when you're doing backwards. So instead of me going this way, I can go backward. 5 minus 3 will also give you 2. So the difference of 3 and 5 becomes 2. That's where this idea came from. You're going to find the difference of y2 and y1. Same thing as correspondingly, you're going to find the difference of your x coordinates. If you started with a y2, you're also going to start with the x2 on the bottom. Later, many people will get confused whether does y1 comes first or at y2 comes first. That shouldn't really matter as long as you stick with the same order that you started. Let's look into an example. So the first example, as you see, there are no pictures, there are no graphs or tables. You have to find which one is your horizontal change and which one is the vertical change. So let me write the slope formula. The slope, I'm going to write m, is equal to, if you remember, let me go back, the rise over run. The rise was your y value part, so I'm going to find what is your y over x. Another word, we talked about it as vertical change over your horizontal change. This is also relate to your formula that we just talked about. So if you were not sure which one goes on the numerator part, as you see, all my y values are on the numerator. So when you're writing, the y2 minus y1 will be on the top, and then x2 minus x1. Again, don't get confused with the orders. Let me look in this example. So if I have all these coordinates, all these different numbers, later I get easily mixed up. I'm going to write the names of each coordinate. When you are writing a coordinate, you always write x, comma y in that order. So let me write that. Now I want to see the difference. Because you have two same x's, it's going to be confused later. Let me write some numbers. I'm going to call this A as my first coordinate. So I'm going to write x1, y1. This B is going to be my second coordinate, so x2, y2. So then the 3 will be your y2, so 3 goes first, minus, the minus is coming from here. The y1 becomes 2 over. The x2 is representing the 5, so 5 minus, where that's coming from here, the x1. The x1 is 2. Now you're going to calculate this. 3 minus 2, I get 1. 5 minus 2, I'll get 3. So the answer becomes 1/3 for my answer. So let's look at the other example with the negative numbers this time. Before I get confused with so many numbers, I'm going to write what I call the names. So the names for each coordinate becomes x to begin with, and then y. That's how you write the coordinates. So when you write the coordinates, you always have x and y in that order. When you're having two x's and two y's, they look exact same to me. So I'm going to write the numbers saying that this is my first coordinate, x1, y1. This is going to be my second coordinate, x2, y2. So in this time, m becomes, let me draw the line on here, m becomes your y2 to begin with. The y2 is -2 minus, you are having another negative with the -4 over, x2 is -3, and then minus, your x1 is another negative. So here's the thing, when you have -2 minus -4, -2 minus negative, they are inverse of the negative. So I'm going to add 4 over -3 minus -7. So let me write the -3. When you have minus with negative, I'm going to put +7. -2 plus 4 is 2. -3 plus 7, I get 4. I'm going to simplify just one more time, so I get 1/2 as my final answer. This is the end of the lesson. Thanks for learning with me. If you have any questions, please don't hesitate to leave a comment.